All right, good afternoon. Thank you for joining us for this second to last Northeast Cover Crops Council short webinar. I'm Victoria Ackroyd, Program Manager for the Northeast Cover Crops Council, and my co-host is Susan Brulette, who is with University of Vermont Extension. Today's session qualifies for 0.5 crop management CCA CEUs. We will put up the slide with the needed information and the QR code at the end of this session. The talk will be about 20 minutes long with about 10 minutes at the end for questions. Please feel free to put questions in the chat at any point or at the end. Very much you are welcome to speak up. This webinar is being recorded and will be available along with the slides on the University of Vermont Extension website fairly shortly. We do have a closed captioner, so if you need that service, please check the chat for our kind assistant Emily's message about how to access that. Today's speaker is Dr. Sarah Hirsh, who is an extension educator for University of Maryland in Somerset County and an NECCC board member. Her research and extension program focuses on soils, conservation, cover crops, nutrient management, and integrated pest management. Sarah received her PhD in soil science from the University of Maryland in 2018, her MS in sustainable agriculture and ecology from Iowa State University in 2012, and her BS in biology and psychology from Grove City College. Sarah aspires to work with farmers to improve the productivity and profitability of agriculture while conserving soil, water, and biodiversity. Sarah, thank you for speaking today. The screen is yours.
Great. Thank you, Victoria, and hello, and thank you everybody for coming out today. Let me share my screen here. All right. So I'm going to be talking to you today about a project that we're doing in Maryland through University of Maryland Extension, working with a bunch of farmers on trying to experiment or try out different cover cropping systems. All right. Hopefully you could see my slide advance there. Let me know if not. To start off with, we do have some federal funding with the University of Maryland Extension. And so I just wanted to let everybody know that our programs are available to everyone without any kind of discrimination or exclusion. So this project involves a lot of partners. This year, fall, will be our third season of enrolling farmers and trying different cover crops. So these are some of the partners it's funded through 2 different grants right now. And actually we just got, those 2 grants will be ending and we got an additional grant funding. So it will be continued in the next few years. And I'll talk about that a bit at the end and how you could get involved if you are interested in staying informed on our progress with the project. But we do have funding from the National Fish and Wildlife Foundation, the Natural Resource Conservation Service, NRCS, partnering with some folks at Colorado State, partnering with Future Harvest, partnering with Sustainable Chesapeake, and the Maryland Department of Agriculture. So a lot of partners involved. And in addition, and I'll talk about this, we have overall probably about 30 farmers that we've worked with in one of the 3 years or multiple of those years. So the objectives of this project is to demonstrate on working farms that there's not a one-size-fits-all cover crop, and that cover cropping should involve significant planning with regards to site-specific factors and cover crop purpose. And in order to do that, we're providing farmers with both the technical and financial support to reduce their risk while they try out new things on a field scale. So basically, the idea behind this project was to try to take cover cropping to the next level in Maryland. So Maryland already has the highest percent of crop acreage in cover crops, but still the most common cover crop in Maryland is wheat cover crop. And most of the cover crops are monoculture, so just one species. And again, the majority is the wheat. And farmers tend to just plant the same cover crop across all of their fields or acreage regardless of other factors. So our idea was to try to branch out and try different types of cover crops based on site-by-site factors that may make more sense or be more beneficial for the farmers and for the operations. And also to try some things out on a field scale using the farmer's equipment rather than trying different things in like on a research farm in small plots. So just taking it up to that field scale. So it's pretty straightforward. An extension person goes out and they meet with the collaborating farmers. So we recruit farmers, we put out flyers, we put out email blasts. We try to recruit farmers that are interested in trying something different or new to them in cover crops. And then we go out to plan a cover crop with them. We'll usually try to get out there about midsummer prior to them purchasing their seed and things like that. So our framework for planning, we try to focus on these three pieces. We ask them, what is the purpose or the need for the cover crop in that field? Are you, for example, having a weed pressure issue in that field? Do you want to build your fertility or build nitrogen in that field, build organic matter? Are you having compaction issues? So we try to narrow it down to one or two top needs or goals that a cover crop could help with in a particular field. And then we also look at the window for the cover crop. So by that, I mean, when are the cash crops being grown? When are they being harvested and planted? And where and when does that cover crop fit in to that cash crop rotation? Or maybe how could we modify the cash crops? Maybe we could harvest a bit earlier or plant a cash crop a bit later to expand that cover cropping window. And then finally, we talk about the farmer expectations. So we want to be realistic. Is the cover crop that you're interested in trying, does that actually make sense? Will it have enough time to build the amount of biomass that you want? Do you have the equipment to manage that cover crop? So we just talk about a lot of those factors when we go out and plan with the farmers. So here's an example of one tool that we use to try to understand what the cover crop windows are. And I will bring up, so this is an example of a farmer that we're working with. So here's his cash crop rotation. He has 2 years of corn, followed by soybean, followed by a wheat crop. And he chooses to skip the double crop of soybean, and instead he plants a summer cover crop there. And I'm gonna just come back to this slide a bit later in the presentation today to talk about in detail his cover crop choices and some photos and why he chose what he chose. But for now, I just wanted to show this tool that we use in our planning process to kind of sit down with the farmers, draw out what their cash crop rotation is, and then think about how cover crops will fit in and what are the best types of cover crops to fit in. And then some examples of purposes or goals that that have come up in our planning conversations. So we had one farmer looking to plant a cover crop instead of black plastic, and his primary reason was because he was having a lot of disease in the watermelon from the raindrop splash off of the black plastic. So he in that field was having disease pressure and wanted to get away from the black plastic for now at least. And so he was trying to think about how could a cover crop provide the mulch to replace the black plastic. Another farmer, their primary problem was the deer, and he had an idea that he noticed before that if he planted bearded wheat and he planted the soybean in green to that, then the deer didn't want to stick their nose down into the field to eat the young soybean. So he would have that bearded wheat cover crop still growing, and he noticed that kind of cut back on the deer pressure. Another one was trying to cut back on nitrogen for financial reasons, and the vetch cover crop can be a really good source of nitrogen and allowing him to cut back. So his primary reason was to build nitrogen. Another farmer wanted to try a particular type of mustard cover crop due to some effect that it had on nematodes. So some kind of chemical effect that tilling in that mustard cover crop may help him reduce the nematode pressure, and that was in a sweet potato field. So these are just some examples of the purpose or goals that came up in our planning meetings, and they were trying to design a cover crop to address these. And then it's up to the farmer to plant and manage the cover crop according to their plan. So again, we're being realistic in what equipment do they have access to. It's up to them to buy the seed. We can help them like locate seed, but ultimately it's up to them whether they are spending the money and buying that seed and how they're going to get that cover crop planted, terminated. It's all of their equipment, or up to them to find the equipment and to do the actual work on a field scale. So we then collect a lot of data, and it's both some physical data, but also kind of paper surveys. So we want to know what was the history of the field. So field management history, and we want some of their financial records. What did they cost? What did it cost to buy the seed? What do they estimate it costs to plant the seed? So we could kind of do a partial budget analysis on all these different systems that the farmers are trying and compare the different ones. And then we also had an extensive survey asking farmers about their satisfaction with that cover crop. Were they happy with it? Were they disappointed? We asked them about their planting and through the season, and about the following cash crop. Did they think that it had a positive or a negative effect on the following cash crop? Did they cut back on any herbicide or nutrient applications to the following cash crop? So we really want to look at the whole picture and how they felt about that cover crop, and as well as the finances that went along with that, to get some estimates of the benefits and the costs of these different cover crop systems. And then physically we went out, and the farmers, so kind of a part of the project that I'm not going to get into today is that the farmers were also enrolled in the soil health benchmark study. So we were taking soil health measurements on these fields. So I'm not going to talk about that today, but I will bring in some of the biomass data that we collected. So we did go out in the fall, or actually it was more like early winter, after the cover crop had finished growing for the fall growing season. We got samples of what kind of fall biomass accumulation did we have. And then we went back out to the fields in spring prior to termination of the cover crop to measure the biomass. So we tried to hit the farms as close to termination as possible in the spring to see what the total accumulation or growth of that cover crop was. And then we had different opportunities for farmer to farmer learning. So we had kind of closed opportunities among all of the collaborating farmers. And by the way, this first 3 years of the project were just on the eastern shore of Maryland. So the 9 counties on the eastern shore of Maryland were allowed to apply to enroll. So we had some meetings in the winter, just those collaborating farmers on the eastern shore of Maryland talking amongst themselves with what worked and what didn't work. And then we had open to the public field days. And the goal with those was that neighboring farmers could come out and see what some of our collaborating farmers were doing and trying with their cover crop systems. And these are just some more examples of different field days that we held. And we got into all different topics. So equipment, we had discussions about that. Planting and how the seed size affects the planting and what mixes may go well together. So all different things at those field days. And now I'm actually going to get into some of our case studies. So just for today, because we had a pretty short time together, I'm going to try to hit on 5 different examples of case studies or cover crops that we tried with our collaborating farmers. So this was a farm that he planted a wheat and veg cover crop, and this was a corn soybean grain operation. So his primary purpose was to build organic matter and nitrogen. He hoped to cut back on his nitrogen that he applied to the following corn crop. He planted this cover crop in early September with an aerial ground rig through a soybean fields. Here you could see the cover crop growing. He planted in early September. These photos are showing the growth by October 27th. The beans were still in the field. He didn't actually get in to harvest the soybean until November 18th. So a couple months of growth prior to the soybeans being harvested. And then here you could see the cover crop growth by December 12th. And that was about 340 pounds per acre of cover crop biomass. So pretty small cover crop in the fall growth, but a pretty good stand there. And then you can see, so remember that number, 340 pounds per acre in fall growth. And then by May, we had about 8,500 pounds per acre of cover crop. And again, that's the wheat and the veg there. So in terms of terminating the cover crop and planting his following cash crops, he split the land. About half of it went into corn and the other half went into soybean. So ahead of the soybean, he crimped the wheat and the veg when it was short pocket tall. So a lot of growth there. You could see here, I pulled back the veg and wheat cover crops. You could see an earthworm there. A lot of kind of whole ecosystem going on down there at the soil layer due to all that cover crop and growth. But then he waited after he rolled down the cover crop. He waited about 2 weeks. It kept growing, so it did not terminate the cover crop. And then he went ahead and planted the soybean late May, and then chemically terminated the cover crop after that. You could see a really nice layer of mulch underneath that soybean that he planted all the way into August. You could see still no soil showing there. And then on his corn ground, remember the soybean, he let it get chest tall. On the corn ground, he terminated or tried to spray that cover crop when it was about waist high. He didn't let it go quite as big in the corn. The planter knocked it down and matted the veg somewhat. He sprayed it 3 days after planting with some herbicide. Here's what it looked like at the end of April when he planted the corn into it about waist high. And he had this piece of equipment, this planter with shark teeth. And because of that, he said he didn't have problems planting into that veg, whereas other farmers may have problems because they don't have that kind of equipment that is designed to cut through a material like that. And then here's what the corn crop looked like May 15th, June 5th, and August 8th. So again, a nice corn crop. He did not have issues with the stand, although he was worried because it took almost 16 days for the corn to come up. So he said he almost replanted. He was quite worried that something went terribly wrong, but then in the end, he said he was very happy with the corn that came up. So I'm going to keep on moving right along because we have 4 more. So this is an example of aerial seeded cover crops. And what I wanted to point out here is that the cover crop that he chose to aerial seed with an airplane varied depending on the previous and the subsequent cash crop. So a lot of times farmers would say, oh, well, I'm aerial seeding. I have to just do the same cover crop across all my land or across the whole field. But this was about a 150-acre field. And the pilot had no problem doing half. He actually had them fly on 2 different days and 2 different cover crops. So about half and half for that field. And so where the corn was growing, he flew the cover crop on earlier than where the soybean was growing, just so it could do a better job of getting through that canopy. So he waited until late September to fly the cover crop onto the soybean land to help that seed get down through the leaves of the canopy. And then also prior to the soybean crop, he planted a radish and triticale cover crop, but prior to the corn crop, he planted the radish and vetch. So with the idea that the vetch would provide nitrogen and help the corn, but it would not be needed ahead of a soybean crop. So this is just showing an example of a farmer kind of strategizing and doing different cover crop, both species and timing, based on the cash crop rotation. with the aerial seeding. So here's what the two cover crops look like in late April. You could see up here the vetch and radish. The radish did not winter kill this year. And then in the lower photo, the triticale and radish cover crops in late April. This is an example of a farmer who drilled rye, hairy vetch, and keystone winter pea cover crop. This is a continuous corn rotation and pretty high yielding corn, so about 240 bushels per acre that he's built his yields up to. And he had this grain drill that he used to plant the cover crop. He separated out the winter pea in one box and the hairy vetch and rye in the other box. He found that worked better at getting the stand he wanted and the depths. And I think we can. All right, so here's a little video of the cover crop being planted. He planted about an inch deep. There it is in the corn stubble. So he is a no-till operation, and it was drilled in late October, which is pretty late for a cover crop. By December, it had very little growth. So you could see that's only like 2-inch tall peas. So pretty small growth by December. March, it's looking a lot better. And of course, April. So this is just about 3 weeks later, still a lot more growth. So a lot of examples of, as we know, the more growth you could give it in the spring, especially if it's planted late, the more benefits that cover crop's going to have. So here's an example back to the 4-year rotation that I mentioned in the beginning. And what he did here was, let's start with the wheat for harvest. So he skipped the double crop soybean and did a 10-way species mix of a summer cover crop that was intended to survive over the fall and all the way into the next spring prior to his year 1 corn. So a lot of nitrogen species, kind of like brassicas, legumes, and grasses in that 10-way mix. After year 1 corn, he went in with rye and clovers. Sometimes he would also throw in some winter pea there. After year 2 corn and a head of soybean, he would do either a straight rye or rye plus rape because he didn't feel it necessary to do the legumes ahead of soybean, and then back into his wheat for harvest and the warm season mix. So here's a map of his operation. These different covers here, these different colors on the map show the 4-year rotation. So these are all in different crops and different cover crops, depending on where they are in that rotation. Here's a photo of his summer cover crop mix, what it looked like in September. And then here is what it looked like the following spring. And so that summer cover crop was planted in July. It looked like that in the summer. It had different species that overwintered, and here's what it looked like by early spring the next year. So not as full of stand, but you can see there's a lot of mulch on that ground in between the cover crop left over from that summer growth. And then actually here's what that same cover crop looked like in different fields and in different parts of the farm the following year in the spring. So just year by year, the cover crop can look very different depending on different factors, climate things. So this is the same cover crop 1 year later in different fields on that same summer cover crop mix. And then finally, I wanted to talk about an organic grain operation, and he planted winter pea pretty late, mid-November. Did very little in the fall. So here's a photo of the pea in December. He drilled that. And again, organic operation. And he did that ahead of his corn. Ahead of the organic soybean, he planted rye plus either Balanza clover or rye plus both crimson and Balanza clovers. And those he planted in late October. What he did is he worked the field, and then he aerial seeded the clovers, and then he went back and drilled the rye over top of that. So kind of a combination between planting methods. And he found that the clovers do well aerial seeded. They don't need to be planted deep, but he preferred to then drilled the rye in, and plus by drilling the rye, it helped establish the clover as well with the movement of the soil and all. So he had about well, in the P, it was only 34 pounds per acre of biomass in the fall, so very little. For the rye and the clovers, which were planted about a month earlier in late October, they had about 300 pounds per acre. Still pretty little amount of biomass for the fall growth, but by the spring, here's what they look like. So this was the two fields that had a soybean, the one with just Balanza, and then the other field with, rye and Balanza, and the other field with rye and crimson and Balanza. There's two different types of clovers, and these photos were taken in mid-May, and by then he's up to about 2,500 or 3,000 pounds per acre of biomass. And then here's what his winter pea field looked like by mid-May, and he had about 1,500 pounds per acre of biomass there. So again, a lot of spring growth despite not having a lot of fall growth. I just wanted to finish up by saying, so we worked with, these are the numbers of farmers we worked with in each of the 3 years. For this upcoming year now, we're working with 17 farmers. We did get some additional grant to extend the project statewide in Maryland, and then we're also going to branch out. Right now, we have primarily been working with grain operations, but we're branching out with this new pool of funding to include vegetable operations, micro farms, and operations that have animals to graze the cover crop. So trying some different types of systems for those different types of farms. And we are working on more finalized case studies where we'll go include all of the finance data, the farmer satisfaction survey data, more details of the biomass. So please, if you're interested, shoot me an email and I will keep you in the loop as we have more of these products finished up and can give you some more finalized information, and especially including the finances of the different cover crops. And I'm ready for questions, Victoria.
Awesome. Thanks so much, Sarah. So before you had started talking about your first case study, you had been showing a project design, and John Thurgood said, is that strip application of herbicide? So
Yeah.
going back to that study design.
Yep. So that was the farmer that was trying to get away from black plastic in his watermelon field. And so what he ended up doing is spraying out strips where he would then go early on in the spring, where he would go and put his watermelon transplants in their sprayed out strips. And then in between, he let the cover crop grow later. That was, I think, vetch and wheat. See if I have that. Yeah, I'm pretty sure it's vetch and wheat cover crop in between, and he let that grow about another month before he terminated it and kind of laid that down as a mulch in between. So he had, yep, the strips right there. He sprayed out to transplant the watermelons into there.
Very creative. So that gave him some more time to let the rest of that cover grow out.
Yep, yep. And I think I have a photo somewhere where showing it later on. Let's see if I have. Maybe not. I may have removed that one, but yeah, I do have other photos showing what it looked like later on when that other area had grown out.
Very cool. Thank you. Susan, we are almost at time, so maybe if you could go on ahead and throw up the CEU screen. And John says, are any farmers doing a perennial between the row mulch?
And here's the photo I was thinking of later on, where the 30-inch rows, where he would plant the watermelons there, and that's what the vetch and wheat look like. So perennial between the rows. We worked with one vegetable grower who was trying some white clover and ryegrass. But no, even he did kill that after a year to then redo his black plastic. So no, right now we're not working with anyone doing perennial, leaving the cover crop for multiple years. But I imagine we maybe could find some people with this next round when we're branching out, especially like to include vegetable growers and all.
Very cool. John says, excellent work, thank you, and I second that sentiment. And also thanks to Susan for throwing up the CCA CEU screen. We are at time at 12:30, so we'll give it another minute or so to let folks get the information they need here to log that they attended. I will say, Sarah, I'm absolutely intrigued by that bit about the bearded wheat because deer are an absolute plague in my suburban neighborhood. And I am forever trying to expand my garden beyond my 4-foot fence and just, I may go dig through my seed from years past and see if I've got anything called bearded on the
Yes.
label. So
Yeah,
thank you for
yeah, he
speaking.
says it works, so. Yep. Yep.
Oh gosh.